Ashley.
Hi, Nikita.
Yeah, it's nice to see you again in this meeting. And how are
Yeah.
you?
Oh, I'm good. How are you? Thank you for having me.
And mhm, I'm doing great, and I'm very, very happy to meet you again after some meeting. Yeah. And in previous calling with Miss Desiree, I told and asked her about why environmental data is important, and she also gave me the example of data visualization, and this is really great. And now I'm wondering about the process of creating those amazing data visualization and analysis that you guys do in my NASA data. And I know that you are data scientist and data and web developer, right? In MyNASAData. And can you
Yeah.
share with us about what did you do on MyNASAData project a little bit?
Yeah, I'd be happy to. So for my
Mm-hmm.
NASA data, I am the web developer. So I maintain the
Mm-hmm.
website and make sure everything's
Mm-hmm.
working properly, make sure the design looks good and things stay up to date as our editors update their content. So I make
Mm-hmm.
sure everything stays accessible for everybody, for all the teachers and educators and the public that use our website.
Mm, that's really great that hear about you try to make everything accessible, and yeah, public can see from teacher, educator, and also student can see your great work. And talking about data visualization and what data analysis, what actually data visualization and data analysis mean to you?
Uh, so data visualization and analysis is very important to me because it's how we understand the data we collect. So we can
Mm-hmm.
collect any data we want, you know, but if you don't analyze it, if you don't have a way of actually looking at it, you can't fully grasp what it's telling you. So I
Mm-hmm.
like to visualize data using maps and graphs and charts, and I
Mm-hmm.
like to analyze it using Python just to help give me a big picture of what's going on.
Mm-hmm.
And it's just easier rather than trying to find patterns by my own eye. Using the computer really
Mm-hmm.
helps, maps
Mm-hmm.
especially. I love making maps.
Mm-hmm. And nowadays we have tons and a lot of data collection, and maybe because of that, data visualization is really important to package the big data into a summary that people can understand that data, right?
Oh yeah, it's super important. If people can't understand it, they can't do anything with it. So if we can't make others able to understand the data that we've collected, it's not useful. So it's really important to be able
Yeah.
to help others get
Yeah.
it.
Yeah, it's important to make people understand the data so people can try to figure out what's going on with the data. And yeah, I just wondering about how actually the process of the scientists get the data. After that, they try to analyze the data until they visualize it, and they can communicate the data to make people understand about the data, to make people easy to get what the point of the data. So can you share with us the process of creating data visualization and provide us with some example of that?
Yeah, I'd love to. I have a presentation I can share with everybody. So I'll go
Mm-hmm.
ahead and do that and help step through what I do and how
Mm-hmm.
I
That's
help
great.
analyze the data.
Mm-hmm.
So I primarily have been working on data from the solar eclipse that just happened over North
Mm-hmm.
America this past April. So it
Mm-hmm.
went through Mexico, the United States, Canada, and tens of thousands of people helped scientists collect data by going out and
Mm-hmm.
just using their cell phones and sending us what they saw was happening. So, a solar eclipse, for anyone who doesn't know, is just when the moon blocks the sun. So, the eclipse that we see is the lack of sunlight and the moon's shadow is hitting the Earth. So an eclipse can happen roughly every 18 months, but it's rare for it to happen over land, especially where there are lots of people, just because the Earth is primarily water. So, what happens when a solar eclipse is going on? Well, you'll slowly see the moon start to cover the sun. And as that happens, you can tell that it's getting darker. You'll feel a temperature decrease, and some of the clouds might change. That's what I've been looking at, is how the clouds change, because it's not entirely known how the eclipse could affect clouds. So that's what we're trying to figure out. And we're using citizen science to help us. So citizen science is really anyone out there who wants to collect data and send it to us. We use the app Globe Observer, which anyone can download. It's free for the cell phones. There's the website too. And it's just an awesome way for anyone to make an observation of clouds or anything else in the sky or the ground, whatever they're looking at. We want them to share it with us. So this is the eclipse that happened over North America on the 8th of April this year in 2024. So that is the full path of the eclipse. Now that you see is the path of totality, and people outside of there, so like even those along the East Coast could see partial eclipse. So they didn't get the full experience, but they still got to see some changes going on, which is really neat if they also sent us their data, because then we can compare what they saw compared to what the people in the path of totality saw. So like I said, we're getting data from real people. So I have started with a few different locations where we got really good observations from people. And I have those here in the black dots on the map. The red dots are just central locations where I grabbed, weather station data just to help verify what the people might have been telling us they experienced. The blue is the path of totality from the eclipse, and those red lines just indicate different percentages that people experienced of the eclipse. So we can see I have a pretty good spread here, a lot in the path of totality, and then a good couple outside of that too to help look at it and what's happening and make the comparisons. So we love when people send us data because we can actually use it like this. And the volunteers that send us data, it's so important because their observations aren't always captured by other methods. So here we have a satellite image from the same day of the eclipse. So this is great. We get to see a whole bunch of the globe here, but it's not capturing minute by minute. These are more every hour, maybe every 30 minutes, maybe even every 5 minutes, depending on the technology. So what you see here, all of the white spots represent water vapor or clouds that the satellite sees. Now that can be skewed based on what's happening on the ground, because the satellite might not be able to tell the difference between snow or clouds or something else that could be going on. So that's why it's very helpful to have people tell us what they see too. And you can see here the dark shadow going across the United States. That's the eclipse happening. So I'll let that go through again, just so you can really see it, because it's really neat that you can just tell where the eclipse is happening and when. So you can see it coming up through Mexico. Now it's through the United States, and then it goes through parts of Canada. Here's another video. This is from the ground level. This was from a location in Florida, close to one of the places that I had marked. And you can clearly see the day and when the eclipse happens, and then the sun starts to set. So I'll let that run through again. Daytime. And then here's the eclipse. You could tell it got darker then, and then it got brighter, and then it starts to get darker again because sunset's coming. So I think it's really cool that you can see it happening all these different ways. And then to get the people giving us their observations as well, it's just really neat to have the whole picture put together.
Mm.
So ultimately, we're trying to figure out if the clouds change during a solar eclipse. And the answer is maybe. Lots of studies have been done on this, and we're doing our own
Mhm.
with the GLOBE team, the GLOBE Clouds team at NASA Langley. So we're putting together a lot of pieces right now. We know that the sun can the radiation, as the radiation is blocked by the moon during the eclipse, we know that temperature decreases and then it might change humidity as well, different levels of the atmosphere. So we're focusing on how different clouds at different levels, so different heights in the atmosphere, might be affected. Because everything's going to be affected a little bit differently, and it depends on what else is going on. If there's a storm here or clear weather there, all of it's going to affect how the changes happen, as well as how long of an eclipse that area experiences. So the path of totality, you're going to experience the eclipse for a little bit longer than areas outside that path. So how do I look at this data? Well, I use a lot of different types of tools. Jupyter Notebook is a big one for me. That's where I write my Python code. I use different libraries with that, NumPy, GeoPandas, Matplotlib. Panoply is a really nice software as well, which is developed by
Mhm.
NASA. And that's a good way to help visualize the data and pull out specific pieces that you want to look at. Esri as well. I use ArcGIS primarily for this, but they have other tools as well. So it helps me make maps. For Jupyter Notebook, this is a sample of what a notebook would look like. You can just type in your code and run it as you go along. So it really helps me stay organized instead of just getting lost in what I'm typing. I can section things off and make it easier to follow for someone else.
Mhm.
GeoPandas is one of the libraries in Python I use, and it's great at helping me kind of add maps together. So if I have one type of data here and a different type of data here, but I want to look at them together in Python, I can use GeoPandas to do that. And it's super useful, and I have loved using it.
Yeah.
And then, like I said, I also use NumPy and Matplotlib that helps me with special math functions and statistics and making graphs and charts. And then Esri and Panoply again, they help me visualize the data, more maps, and really pull out key pieces and give me data tables. And it's all just a great way of helping me visualize and analyze the data. So that is what I have for you here.
That's a great point that you say about uh although we have satellite technology to see the surface of the earth, but we still need you still need the scientists still needs people help to identify, is it really a cloud or is it snow, because the white the white thing in the satellite maybe show the different thing, and yeah, people can actually see the thing better than satellite, and that's the evidence that citizen science play an important role in this project, right?
Oh, yeah. They play a huge role, especially since people will move to where the neat things are happening. So, people from all across the country tried to move to the path
Mm-hmm.
of totality for the eclipse, and they were able to help
Mm-hmm.
us get data. Whereas, if they are originally off, pretty far away, they could still help us, but they're able to make a bigger impact by experiencing the eclipse for longer and giving us more data. So
Mm-hmm.
it's super important that people are able to help us, and we appreciate everyone who does.
Mm-hmm. And the combination of variety of technology can help do the comparison. So we have like satellite technology, and then maybe weather station and people observation to do a research, right?
Yes, lots of different data sets just to really help tie the picture together. Because maybe
Mhm.
people aren't going to be the most consistent, but you know that the weather station's going to be making observations every few minutes or so. But the people are going to give us pictures and the actual event that's happening that they're experiencing.
That's a great point that people observation will show us the actual event that happened. And talking about the data visualization that you share with us, can you share about the process of doing that? And yes, do the some example that you have in your environmental data, maybe in MyNASAData or the other source.
Yeah. So I will gladly share the MyNASA
Mm-hmm.
data examples.
Mm-hmm.
Now I know Miss Desiree helped show you guys some of this too. So I'll try
Mm-hmm.
not to repeat too much of what she did. So here we have the beautiful website, which if you haven't visited it before, please do. We have lots of different resources here for all different types of things going on the earth. So, like air
Mm-hmm.
quality or temperature changes, how plants are changing, etc. And we have our own solar eclipse part here.
Wow.
So, this is a super neat resource for anyone who's trying to learn more about the eclipse. So, I'll just scroll through and show you guys a little bit. We have even here from Globe how solar eclipse affects air temperature, how different locations experience the 2024 eclipse.
Mm-hmm.
So, a way that I could look at the data is by using the MyNASA data visualization tool, the Earth System Data Explorer,
Mm-hmm.
which Miss Desiree, she largely invented this herself, and she did a
Mm-hmm.
fantastic job. So if I wanted to look at solar eclipse, I might want to look at air temperature. So I'll want to compare how the temperature is changing. So if I take a look at daily surface air temperature, I can go to the day of the eclipse. Now, here tells us a little bit of what that day in total looked like. So I know what I'm looking
Mm-hmm.
for to see if people's observations that they sent us are completely wrong, if they give us an observation that's, more extreme than what the rest of the data sets are telling us. So I'll zoom in a little bit, and we know the path of totality went kind of across the United States like this, from Texas out through Maine, over Canada and the Great Lakes. So not only would I be interested in temperature, but maybe I'd want to use the compare to tool and maybe look at clouds. Now this might not have, the temporal scale that I would ideally want,
Mm-hmm.
but this is still an excellent tool to use. And it can give me a generalization of what that day looked like. Because I
Mm-hmm.
know a lot of areas in the United States were cloudy. I, for
Mm-hmm.
one, was in a very cloudy area and did not get to see the eclipse very well. But that's okay. I still made my observations and said, hey, I see clouds.
Mm-hmm. Mm-hmm.
So here
Yeah.
I spoke about the different levels of clouds. So I chose
Mm-hmm.
specifically high level clouds here, and cirrus type clouds are primarily found at this level. And those are the types of clouds that I'm really focused on right now in my research.
Mm-hmm.
So I've also looked at lower level clouds, but these upper level
Mm-hmm.
clouds are the ones we're focusing on right now to see if something interesting is going on there. So I could
Mm-hmm.
use this compare to tool and see, all right, it was warmer here. Maybe there are some spots in Pennsylvania, New York, where it's a little bit cooler. Now, how did the
Mm-hmm.
clouds reflect that? Because maybe if it's cooler, you could expect there to be more clouds that are blocking the radiation if they formed when the sun would be, trying to give all of that radiation and that heat to the earth. So I would use tools like this. And you can see it's a map. Love having a map that I can look at and just really visualize it and go more in depth, zoom in and out. It really helps me see the data and understand what's going on more than if I were just reading off coordinates and looking at values. I would get lost doing that.
And do you have the other example of data visualization, maybe related to solar eclipse or the other thing?
Yeah, so I showed that map that I've made. Since we're still working on the data and the analyzing, we don't want to give out too much yet. But I have more maps that like the one that I shared where I have different points scattered, and I can show the where all the weather stations are that I'm looking at, where the satellite was looking. I have all of the volunteer data sets mapped out in different locations across the United States. We had some all over the world. Mexico gave us observations, Canada did, even Portugal and the Caribbean islands.
Wow.
It's really nice to see that using a map, I can really grasp how many people are using the tools and giving us data and sharing their experiences with us.
And you use GeoPandas to combining the data from different places, right?
Yes, I use GeoPandas for that in Python, so that really helps me see how everything is oriented in the world, and then Esri as well from making the maps and making them more visual. I find Esri easier to work with when I'm making a map to share with others because it helps me be easier to make it accessible for those who might be colorblind or something like that. So I like using Esri for making the maps that I'm sharing with someone, and I like using GeoPandas to help give me a better, quick idea of what I'm dealing with.
Yeah, that's great to hear about. You use some tools to visualize the data. You use Python and GeoPandas, so
Oh yeah,
there are
lots
some
of things.
helpful tools.
Oh yeah, there are so many, and I'm sure there are more that I even forgot about. I'm always learning. I love learning and finding new ways to look at my data.
And we, as maybe student, we also learn from you.
Yes, I think everyone can always keep learning. That's one of the best things to do in life.
Yeah, and everyone can teach, everyone can learn.
Yes, absolutely. We all know different things, and that's how it should be. So we can all teach each other.
And we actually have a question from our audience. Can I share it with you?
Yes, please.
Hello, Nikita. Hello, Miss Ashlee. We have a question from Garcia. Can you tell us some visualization methods we can use for each purpose? Thank you, and bye-bye.
Yeah, thank you for the question. So finding the right method can be tricky, and even scientists can get it wrong sometimes. I know I certainly might not always choose the right tool, the right map, that kind of thing. So depending on the type of data, you might want to use a line plot. If you have a time series data and you want to see how something's changing, or maybe you want to use a bar graph if you're more comparing something to something else. And the maps, if you have location-based data, which is primarily what I work with. And then once I get into doing statistics, I'll probably show more of a graph or a line plot to help demonstrate how one specific location has been changing over time. But it is tricky to really get it right the first time. So a good way to tell if you're using the right method to look at the data is to give someone else the tool that you created, the map or the graph or the chart, and ask them what they see in that. And if they tell you what you think you're trying to show, then you know that you're doing a good job. Otherwise, you might have to revise what you're doing in your method and find another way that might fit a little bit better.
Hmm. That's a great point that sometimes it's tricky, but if you see that the data is time series, maybe you can try line plot for
Yep.
that. Mm-hmm. But to make sure that it's understandable or not, you can maybe ask for some help to try to tell what they see. And yeah, if they understand that, we do a good job. But if uh, they think that they don't really understand, maybe we need to revise that. So that's the point, important point, that we still need someone help to
Yeah. Yeah, it's okay
make
to ask for
sure.
help.
Mm-hmm. Yeah. And how is your research go about the solar eclipse? Does the research actually tell what's the change happened in solar eclipse, or you still need some data maybe in several years in maybe several years of solar eclipse, and you need a lot more data to maybe find the evidence or the accuracy of your research.
Yeah, so of course, the more data we have, the better. So it's always
Mm-hmm.
nice to look at other data that came from other
Mm-hmm.
eclipses. We
Mm-hmm.
also have data from an eclipse that happened in 2023. It wasn't a total
Mm-hmm.
eclipse, but it was a partial. So we still got similar data sets from the volunteers who made observations for us. And then we had an
Mm-hmm.
eclipse in 2017. So I'm pulling data from these and comparing and looking at, and then I'm also reading papers that people have written on data sets from solar eclipses in other countries. So that's really helpful, and it gives me an idea of what seems likely to happen versus what
Mm-hmm.
might not be as likely to happen and could have been user error or something. So the more data, the
Mm-hmm.
better, always.
Yeah. And the more when we get more data, we can do more comparison, right?
Yes, absolutely. And the more data that you have, the more likely it is that people are in an agreement with what they saw, with what happens. If you have one point here, one point there, and they disagree, it's kind of hard to tell, well, what was really going on. But the more you have, the easier it could be to identify what might have actually been happening.
Mm-hmm. Yeah, that's a great point. And I I want to ask a question again. From your perspective, what element or what skill that we need to develop or improve to optimize our data analysis or data visualization project?
Ooh, yeah, that's a good question. I think I think a great skill to work on is just being able to find patterns. If you
Mm-hmm.
can identify patterns, even if it's just a small one at first, you might be able to take that and go further with it. Because you could look at a bunch of
Mm-hmm.
data and think, I have no idea. I have tens of thousands of data points right now. What do I do? I'm going
Mm-hmm.
crazy. But if you can just start looking for some sort of pattern, maybe pick one location and just look there. Okay, I see that maybe everyone's reporting that the temperature started decreasing and it started increasing again. Well, there's your pattern. You know that as the sun was getting blocked, the temperature was changing. And then you can take that and run with it and apply that pattern to other locations and see if it's the same thing. So I'm very much a pattern person. I like seeing what patterns I can identify because then that just helps me come up with other areas of where something might be going on.
Mm-hmm. And what is your favorite pattern
Ooh,
that you like to observe?
um, So I love weather. That's what my education is in. I did a bunch of years in school learning about weather and climate. I I really like storms and storm patterns. So you'll learn where places are more likely to have more moisture in the air, and that helps storms form. So, right now for North America, it's the hurricane season. So we are paying close attention to the Atlantic Ocean right now and seeing how the hurricanes are forming. We've had a couple already out there that we're watching. So with the patterns that we have from previous hurricane seasons, we can get an idea of how these storms might act and where they might go. And everything that we've learned over the past few decades and hundreds of years, they help us identify just how the weather is kind of working. So I love anything that's a weather pattern.
Okay. So you love about the weather patterns such as
Yes.
thunderstorm maybe or maybe
Yes.
cloud.
Yes, I love all of it. You can't have a good earth without the clouds. The clouds really give us a lot of what we need to sustain life, like rain.
Yeah. That's a great point because we need our earth and we need to always observe our weather, right?
Yes, yes. We need to be prepared for what might be coming, what storms we might have, when the power might go out, that kind of thing.
Yeah, that's true. I agree with you. And thank you so much for sharing a lot of insightful things from how the process of creating data, and you share us about the tools, and then you share us about the MyNASA data, and then you share the visualization between the temperature and then clouds, and yeah, at the end you share us about what skill that we need to improve to do a data visualization and data analysis. And the thing that we need to improve is trying to see the pattern of the thing.
Yes, yes, that is definitely my recommendation. Finding a pattern is just a good place to start. It might turn out to be nothing, but you have to start somewhere, and sometimes it can be just too overwhelming, even for me. So you just got to start small somewhere and maybe find a pattern.
Yeah. Yeah, and thank you so much, Miss Ashley, for everything you share with us. And I want to say thank you for our audience, Sobat Kokamuhi, for coming to our channel, for coming to Kokamuhi channel. And visit our channel. And hopefully you can get some insightful information, and you can try to analyze and visualize data uh, from the tips that Miss Ashley shared with us. And before we close our show, let's do I think I call it a slogan or jargon. So usually we do like I count 1, 2, 3, I say salam, and we say superhero together.
Sure.
Do you want to do that, Miss Ashley?
Yeah, let's do it.
Just to encourage our audience.
Yeah,
Okay.
I like it.
So 1, 2, 3, salam.
Superhero.
Superhero. Yay. And thank you so much, Miss Ashley, for sharing everything that you have. And thank you so much, Kokamuhi. Stay tuned. Stay tuned in next episode. Hopefully, it will help you to explore about environmental data. And bye bye. See you next time.
Thank you for having me. Thank you, everyone.